Today we're going to do, I think, about 6 problems. The first 2 are going to be something we did yesterday. We graphed piecewise functions yesterday. We're going to start out by doing that again today. The first one is going to be 2-piece. The second one we haven't done yet. It's a 3-piece piecewise function. But let's get warmed up with the one we did yesterday. Like I said, split it up. Do one at a time. We do the first one. We get y equals negative 3x minus 4. What's the first step we're taking when we're graphing piecewise functions? Finding the... Someone said it. You might have. What'd you say? The x. The x at the endpoint, right? We know what the endpoint is. So we're letting x equal negative 2. Right? Find your endpoint. X equals negative 2. Plug it in to find our y value. Negative 3 times negative 2 minus 4. Well, negative 3 times negative 2 is 6 minus 4 equals 2. So at negative 2, 2, I have an endpoint. Is it an open or closed endpoint? Closed. It's or equal to here. So this is closed. Okay? So at negative 2, 2, I have a closed endpoint. Then, I need to fit one more, find one more x that is less than or equal to negative 2. So I'm going to let x equal negative 3. Right? Let x equal negative 3. Find your direction. This is going to tell us which direction we need to go. Negative 3 times negative 3 minus 4. I get 9 minus 4, which is 5. So I know negative 3, 5 is another point on this line. It's showing me which direction I'm going to draw my line in. Once I have those down, I can take my straight edge out and draw my line. Start at your end point, go through the direction point. Okay, that's part 1. Part dos. Y equals x plus 1. Right? First thing we're going to do is find our end point. Let x equal negative 2 again. Let x equal negative 2. Negative 2 plus 1 equals negative 1. So my y value is negative 1. Negative 2, negative 1 is my endpoint. Should it be open or closed? Open, right? It says x is greater than negative 2, not or equal to. So it's an open point at negative 2, negative 1. And I'm finding direction. So I need greater than negative 2, so I'm going to let x equal negative 1. Negative 1 plus 1 is 0. So I get negative 1, 0 is my other point. Once again, once I have my direction on there, I can draw in my line. That's not the right color. And that's my piecewise function. So, remember, always find the endpoints. Then find a point that shows us the direction, and then we can draw them in. Alright? Any questions? Right, the last one, we got negative 2, negative 1. They plug in negative 1, we got negative 1, 0. Okay? Any questions? Alright, the next problem. It's a 3-piece step function. We haven't done one of these before. We've not graphed a 3-piece before. It is very similar. So, same thing I'm going to do is I'm going to break it down into 3 pieces now instead of 2. 1, 2, 3, because there's 3 of them. The first one, y equals negative 1, right? Y equals negative 1. My endpoint, I'm going to let x equal negative 1. Well, when x is negative 1, y is negative 1. That's my endpoint, right? It is a closed endpoint. It's less than or equal to negative 1, so it's closed. So at negative 1, I have a closed endpoint. What's another x value that's less than or equal to negative 1?
-2.
-2. So let x equal -2. I get -2, -1. So -2, -1 is another point on my line. I can go ahead and draw that one in.
Uh-oh.
Yeah, uh-oh's right. Messed up.
Ooh. On camera, too.
There we go, I fixed it. No mess up anymore. Alright, so that's the first part. The second part. The second part's where it's going to be different. The second part, I'm going to have 2 endpoints. So those are the 2 points I'm going to use. Alright? Normally we have 1 endpoint and then we have 1 to show us the direction. The second one has 2 endpoints here. It's got -1 and +1. So when I go to say y equals 1, I'm going to let x equal -1, and then I'm going to let x equal 1, because then I'm going to get the 2 endpoints for that piece. So let x equal -1. I'm at -1, 1, with an open endpoint, right? -1 less than x. So -1, 1 is an open endpoint. And then I'm going to find my second endpoint as well by letting x equal +1. So let x equal +1, I get +1, 1. And now I know because those are the 2 endpoints, I can draw my line in between the 2 there. So now I have 2 pieces on my graph. I need to find the third piece. Does everyone understand how we find that second piece where it's in between the 2 endpoints? Okay. So the third piece here. Third. We get y equals x. So this is how we've been doing it before. Find your endpoint. X is greater than 1. So let x equal 1. We get y equals 1. At 1, 1, I have an endpoint. Is it open or closed? Open. Right? It's just greater than 1. So it's open. Now I do have a point there already. I'm just going to draw another circle right over it. Right? Still open. That's fine. Then, I know I'm trying to work greater than 1. So what's another x value greater than 1? 2. So let x equal 2. In this case, I plug 2 in, I get y equals 2. So then at 2, 2, I have another point. That's the point that's going to show my direction. So 2, 2. Now that I've seen my direction, I can now draw in my line. Oh, that's not right. And that is my 3-piece piecewise function. The big difference between that 2 and 3 piece piecewise is that we're using 2 endpoints for our middle piece. All right, we don't need to find the direction because we can just use the 2 endpoints. Okay? Yes? Any questions? Pretty easy so far? All right. Next. Given the following step function, evaluate the following. So, we've not talked a whole lot about step functions, I don't think, yet. But step functions are just like a piecewise function. There's different parts to them. They look like steps, right? That's why they call it a step function. Right? So we're going to try and evaluate them because, who knows, it might show up soon. I don't know. Maybe? Maybe. It might.
Does it?
It doesn't. It means it might. So,
Liar.
if I'm asking you to evaluate these, we evaluate them the same exact way that we've evaluated other functions. Alright? If I am looking for f of 6, where do I look to find my answer? Where x equals 6, right? So where x equals 6, I need to find the closed point. Remember, the open point does not count. We're not including it. So where x equals 6, I need the closed point, which is at +1. 0 is not an answer. That open circle means it is not included. Same thing for f of 2. If x equals 2, I'm looking, I have a closed point here, I have an open point, I want the closed point. So it's going to be -3. Does that make sense?
Yep.
Right, remember, those open points are not included. Same thing over here, I have f of -1. Looking at -1, I have a closed point right there, so I know it's going to equal -1. And f of 3, open point, not included. I'm going to keep going. The closed point is at +3. Yes, Jalen?
Wouldn't we use like an inequality then, so we know like what direction the open points are going to, or does that not matter?
Because we're not drawing them, it doesn't matter. All that we're worried about is trying to evaluate this. So we're letting it x equal, 3. That's a 4. And we know because it's open, we can't actually include it in an answer. Does that make sense? Okay. All right. Any questions on that? That's pretty easy, right? Okay. Last thing we're going to do today is we're going to write piecewise functions from a graph. All right? It seems to be really difficult. It's actually going to be really easy. All right? What are the two things we normally need to write an equation of a line? Slope and y-intercept. Do we all know how to find slope?
Yeah.
Perfect, then we should be able to do this. Okay? So let's look. I'm going to label this as line 1. This is line 2. So I need to find the slope and the y-intercept for both lines. I'm going to start with line 1. Line 1, I'm looking. I have a point here, point there I can use. I go up 1, over 1, up 1, over 1. What is my slope going to be? 1, right? 1 over 1 or just 1. Now, does it show a y-intercept on here? No. But could we keep going to maybe see where the y-intercept would be? Over 1, up 1, over 1. Where would my y-intercept be?
5.
E would equal 5. So the equation for my first line is y equals x plus 5. All right? We understand that? Okay? Well, I need to figure out where does this happen? When x is what values? Well, where's the endpoint at in reference to x for the first line? -2. Right? Am I going less than -2 or am I going greater than -2? Less. And is it going to be or equal to?
No.
It's an open circle. So I know this happens when x is less than -2. Does that make sense? You need to find the endpoint, figure out is it less than, greater than, less than or equal to, greater than or equal to, and that'll tell you where that's happening. Okay? Does that make sense? Yes. No.
Yes.
Okay. The second line, do the same thing. 2. Find the slope. Find the intercept. Well, I know there's a pointer here. My intercept's going to be at -2. And my slope is going to be down 2 over 1. So my slope is -2 as well. So my line, it has an equation of y equals -2x minus 2. Right? Plug in your slope, plug in your intercept. And I need to figure out where does this happen? Where's my endpoint? It's at -2. And I know it's going greater than -2, and it's also filled in, so it's or equal to. So x is greater than or equal to -2. Okay? I found everything I need now to write my piecewise function. Do not leave it like this. Yes, you have a lot of great information here, but that is not an answer. Right? We need to write our piecewise function. I'm going to use f of x. You can use g of x, h of x, whatever you want. F of x equals, in our nice little bracket here. List them out. X plus 5, comma, x less than -2. -2x minus 2, comma, x greater than or equal to -2. Right? X plus 5 if x is less than -2. -2x minus 2 if x is greater than or equal to -2. Does that make sense? Some of you look like you're still confused. Are there any questions? Yes, sir.
How do you find out like the sign again?
This sign?
Yeah.
So like if I'm just looking at, this is my endpoint, right? So it's filled in, so I know it's going to be or equal to. And then where's it going on my x values? It's going greater than, it's getting bigger. Right? It's taking -1, 0, so on and so forth. So I know it's going to be greater than -2. Okay? Alright? I want you guys to try the last one. Go ahead and try it. I'll put my answer on the board in a second. I'll leave this one up here if you can use it as a reference. Guys, it doesn't matter which equation you put on top, which you put on bottom. Right, as long as you match up what our x values are going to be with the actual equation. Oh, it looks good, yeah. Looks like you're trying to like hug it. Hug your equations. Alright, some of you finished already. If you're not, keep working, it's perfectly fine. I'll put the answer up here. We can go through it in a couple minutes if you, or a couple, let's say a minute. With this. Down this one. Good? Where's slope here? What's our slope in this one? You good? Good? Good at this table?
Yep.
Good here? You good? Sure? Questions? Take this one. So this is the sign here, right? So where's our endpoint? It's at 1, so we're using the x value. So I know it's using 1 and x. Am I going greater than 1 or less than 1 with that line? And is it open up to 1? So I know it's x is less than 1. It'll suppose it when less than or equal to. Good. Alright, so let's look. Our top line here, it has a slope up 2 over 1, so slope of 2. If I map that down, my y-intercept's going to be at +1, so 2x plus 1, and I know it starts at x equals 1. It gets greater than or equal to, so x is greater than or equal to 1. Our bottom line, up 1 over 2, so a slope of 1/2. Y-intercept at -3, y equals 1/2 x minus 3, starts at x equals 1, and goes less than, so x is less than 1. So we write it out, f of x equals 1/2 x minus 3, if x is less than 1, 2x plus 1 if x is greater than or equal to 1. Any questions? Cool beans.